Hi, welcome to our EEA AskAnExpert. Today we are discussing the synthetic chemical Bisphenol A. My name is Consul Brand from the EEA Communications team, and joining us today is our expert Magnus Lofstedt. Welcome to our episode today.
Thanks.
We recently published a briefing on Bisphenol A, but I guess the first question, before I get to the questions actually, if you're joining us and watching us live, feel free to drop a question or a comment in the comment section just underneath, and we'll make sure that Magnus sees the questions and hopefully can answer them for you. Magnus, let's get started on this rather important subject. Why should we be concerned about bisphenol A?
Well, first of all, bisphenol A is a chemical that is used in quite a lot of different products, and that means that we are all exposed to bisphenol A every day in small amounts. This is not necessarily a problem. But if the exposure exceeds the safe threshold level, then you might have an issue. And that's actually the case for bisphenol A, because you could say previously it was assessed to be safe in use, but now recently the safe threshold level has been lowered by a factor of 20,000, so that's really a lot. And that means actually that we are getting into an area where we have a concern for the current exposure to bisphenol A.
Mm-hmm. And I guess for some people who are watching, what is bisphenol A and how is it used?
Yeah, well, it's an industrial chemical that is used to manufacture a number of different products. For example, it's being used quite a lot in different types of materials that are used to store food.
Mm-hmm.
So hard plastics, but also something called epoxy linings, but that's what you normally find inside metal cans to store, for example, tomatoes or other kinds of canned food. And that's why you can find bisphenol A in small amounts, because when you produce these materials, bisphenol A is completely used in the process. So it's only really small amounts that are left in the finalized materials. It's like it's cured, so you don't get a lot of bisphenol A, but you get a little bit out of these products.
Mm-hmm. And then the area of concern is that they somehow leave the container itself.
Yeah, so then you could say the small residual impurities in these materials, they can leach out into the food, and then when you eat the food, you also eat the bisphenol A and take it up in your body.
Mm-hmm. So how is it a risk to our health?
Well, it has been known for actually quite many years that bisphenol A is an endocrine disruptor, so it can disrupt our hormone system, and it can also affect our fertility in a negative way. But what has more recently been discovered is that bisphenol A can also affect the immune system, and it can do that at very low levels of exposure. So it can lead to some autoimmune diseases, like, for example, asthma. Okay. And the newest assessment that has been made from the European Food Safety Authority is targeting exactly this immunotoxic effect of bisphenol A.
Mm-hmm. Okay. Now, you've led the work here on a briefing that we published just a few weeks ago. What did the briefing say? What did it find?
So we wanted to look into how much are people actually exposed to bisphenol A in Europe. And to do so, we had some data from a recently conducted human biomonitoring project that was run across different European countries. And we had data from 11 different countries. And then we compared this exposure. So this was the content of bisphenol A in urine from these countries. And then we compared that to the safe threshold levels that we had from this assessment made by the European Food Safety Authority. And what the briefing actually showed was that exposure is too high. So we are actually exposed above safe threshold levels to bisphenol A in general.
Okay. And we can have the link to the briefing in the comments section for you. Again, if you have any questions or comments, do drop a line, and we'll make sure that our expert can answer them for you today. So another question is, well, what about the wider impact on the environment of this chemical?
Bisphenol A is actually a little bit different compared to some of the chemicals that we are normally worried about in the environment, because it's not very persistent. It means that it's actually being degraded when it enters the environment. And also it doesn't bioaccumulate in living organisms to a large extent. So it's being broken down in the body and it's being excreted. So therefore, you could say the biggest concern is the constant exposure you have to small amounts, and not so much bisphenol A going into the environment and then staying there for many years. This is the concern you have for several other harmful chemicals, like, for example, I think PFAS is one of the examples that has been discussed a lot lately. Those are really persistent and they can accumulate in food chains and so on. Of course, bisphenol A can also have an impact to the environment if the exposure and the release of bisphenol A into the environment is high enough. But you could say, like, on a scale, I wouldn't rate it as the concern as high as for the environment as for human health.
Mm-hmm. So it stays in the human body longer, or?
No, it doesn't stay for very long in the human body either. That's also why we can measure it in urine. So we're actually taking it in, but we're also excreting it. And that's, the difference from some of the PFAS compounds. You take them in and they stay in your body forever. Yeah. It's just that it has a very high toxicity. So even though that you are only, you excrete it, then it can still have an impact from the direct exposure you have from the different types of products that you're using.
Okay. Can you explain a bit about the research done by this human biomonitoring product across Europe?
Yeah. I mean, I guess in a way that many people think that we are having, like in the EU, we measure chemicals in people's bodies, but we don't do that like on a very systematic level yet. But some member countries are having some human biomonitoring programs, but as opposed, for example, to the environment where we measure chemicals in surface waters or drinking waters, we don't have a EU program to measure chemicals in people's bodies. So this EU-funded research project was really to get information from different EU countries on the content of chemicals measured in humans, but also to harmonize the methodologies so that you can actually compare results from different countries when you measure chemicals in urine or in blood. Mm-hmm. And bisphenol A was, of course, one of the chemicals that was included in this program, and that's the data that we have used in our briefing.
Okay, interesting. We have a question already from Zoe Eleni Moragli. How do we prevent this substance from entering our bodies?
That's a very good question. I have to say, I mean, there have already been a lot of different types of restrictions on bisphenol A. And that's, of course, the best measure to not get them into the products where you can be exposed to them. So, for example, in earlier years, it was used in baby bottles. That has been banned now.
Yeah.
It has also been used in thermal paper that is used for receipts. It has also been banned now. And there has been some limits on how much that is actually allowed to leak out of products used to store food in. So there has been a lot of regulatory measures, and I think that's probably the most effective way to reduce exposure. Mm-hmm. I think there is very little you can do as a normal person trying to live your life, because there are no labeling requirements, so it's not really possible actually to see where is bisphenol A.
Right. So when you go to shop, it's hard, the plastic container you buy or whatever, you just don't know.
No, it's not labeled.
Yeah. Okay. Here we got some more questions coming in. In the meantime, I also have a question for you. What future research do you see on bisphenol A?
Yeah, so this EU project, HBM for EU, it ended now. So there is a new EU-wide partnership called PARC, Partnership for Assessment of Risk to Chemicals, which is continuing, you could say, the work on human biomonitoring. It also contains a lot of other issues like risk assessment and so on. But for human biomonitoring, it will continue to deliver measurements of bisphenol A in human urine. So we will actually be able to track if there is a downgoing trend. Many of these different restrictions that I just mentioned were introduced quite recently or went into force quite recently. And that means that I would expect that the next time we get some results, we would see a lower exposure to bisphenol A.
Okay.
Whether or not it will be below the safe level, that's a good question. But at least I would expect it to be a downward trend for the future.
And who sets these levels? What are health safety levels?
The safety levels for bisphenol A has been set by the European Food Safety Authority, EFSA. and that's because you could say that they are in charge of chemicals that are being used in food contact materials, and the largest exposure to bisphenol A is probably from this product group, and that's why they have been in charge of this assessment. So the EEA has not performed we have not performed our own assessment, risk assessment of bisphenol A, but we have sort of relied on the data that has been supplied and the assessment that has been supplied by our sister agency, EFSA.
Right. We have a question from Anna. Do you find bisphenol A in the air? And if so, from what sources?
I wouldn't expect to find it in air as such, but there might be some bisphenol A in dust. So, and you see that not only for bisphenol A, but from actually many other chemicals accumulate in dust. They sort of bind to the dust, and then you can inhale the dust particles. So that's a very good reason why you should clean your home once in a while, and also get some fresh air in there. Yeah, exactly, because actually dust is an important contributor to our intake of different types of chemicals.
Okay, interesting. So I guess the big question is, what are authorities doing about this? What is the EU doing about this?
Yeah, I mean, there has already been done quite a lot, and I think it's fair to say that in the EU we have the most comprehensive and protective legislative framework for chemicals in the world. But of course, the system is not bulletproof, and I think bisphenol A is probably also showcasing that we continue also to find substances that are more toxic than we previously thought. Adding up on all these restrictions that have already been sort of implemented in the EU, the European Commission recently announced that they are now working on a ban on bisphenol A and other bisphenols in food contact materials. So this proposal will probably be put forward at some point in time, and then it will be discussed between member states and so on, and then we'll see what happens from there.
Mm-hmm. So for clarity, so there are other bisphenols as well.
Exactly, and this is also a good example of trying to avoid regrettable substitution, so that you don't just ban bisphenol A and then you have bisphenol S coming in instead. So that's also a part of the equation, that you want to make sure that the chemicals you're going to use instead of bisphenol A, that they are also safe.
Yeah, I guess that's also the struggle we've seen with PFAS replacements, that industry is struggling to find a safe alternative to these.
Yes, and for PFAS the problem is even bigger, because there you have maybe 10,000 different compounds, so that's really a big task, whereas for bisphenol A, even though it's a big task, I think it's more durable to look for the alternatives.
Mm-hmm. Another question coming in now, that's great. Again, if you have questions, you can jot them down in the comment section or comments, and we'll get to you. From Benito, hello, I'm a chemist. I'm building a method for detecting BPA in biota. I'm trying to detect it with, this is very technical, GC/MS without derivatization. Is this a valid approach? This seems to be very technical.
Yeah, I think actually I will not be able to answer that. Yeah. I know that there are methods for detecting BPA in biota already, but whether or not this would be like perhaps a better analytical techniques than the ones that are already being used, I'm not in that way an analytical chemist. I'm a biologist by training, so it goes beyond my area of expertise to answer that question.
No problem. Is there a limit for BPA in biota in the EU?
I mean, there are different limits for BPA depending on where we look. So, for example, the threshold that I referred to was set by EFSA. That is a limit on how much you can take in every day. So it's expressed in bisphenol A per kilo body weight per day from all the different sources. Then you can have a different limit value in drinking water for bisphenol A.
Okay.
It's also something that are being introduced now in the Drinking Water Directive in the EU. You can have a limit value in surface water, protecting the aquatic environment, and you may also have it in food sources if that is relevant. Normally, the normal approach is to put limit values in fish, for example, if substances tend to bioaccumulate.
Right.
Because then it's important that you look at the fish and not the water.
Yeah.
So I'm not really sure if you have it for bisphenol A in fish, but at least you have it in surface water.
Okay. Question from Julian. Hi, you mentioned a number of chemicals monitored through this project. What are they, and how can they impact our health?
Yeah, I mean, there's a number of different chemicals. I can't remember all of them on the top of my head, but I know that at least a number of pesticides have been included, PFAS, a number of PFAS compounds, because that's also a very large group.
Yeah.
And then for not only bisphenol A, but also a number of other bisphenols like bisphenol F and bisphenol S, as far as I remember, was also included here. And then a number of metals, and then some more, I can't remember. But you can actually find it. There is a web page, HBM for EU, where you can look it up. And you can find also data on how much is measured across Europe for these chemicals.
Yeah, and we'll put the link to the HBM4EU project and the PARC project in the comments section, so you can dig around in that one as well. Another question from Zoe. Proper recycling practices will eventually prevent the substance from entering the environment. Will this minimize the exposure?
I think bisphenol A is a good case where regulations should work relatively fast. Because, as I said, it's being broken down when it enters the environment, at least under most environmental conditions. And this means if you actually put, restrictions on the substance, you will have less going out. And then, of course, many of the products where bisphenol A is have a short life. Like I said, like metal cans.
Yeah.
It's not something that stays on for years and years and years. You eat the food and then you discharge
it's
it.
a good question, because when you recycle these, they stay in the metal? Do they stay in the plastic for the new can that might be made out of the metal? Or
I don't think so, because then you would extract the metal part and you would probably burn the plastic part in order to extract the metal, and then you would get rid of the bisphenol A in that way. And it would be broken down when you sort of melt the plastic. So I wouldn't be too worried about that. There could be a number of applications where you could see products that have a longer lifetime, like building materials that are used for houses, stuff like that, where you could say, okay, those types of products, they would stay for a very long time before they actually enter the environment or the human body or wherever they go.
Okay. Another question from Philippa. What do we know about the alternatives? I mean, I imagine there are other chemicals that are being used to replace bisphenol A. What do we know about the safety of those?
Yeah, that's actually a very good question, because that comes down to this, regrettable substitution talk, and when we're looking into alternatives, we are always discussing you can have bisphenol alternatives to bisphenol A, and then you can have non-bisphenol alternatives. And we would rather have the non-bisphenol alternatives, because for the bisphenol alternatives, like you have bisphenol S, bisphenol AF, bisphenol F, and so on, you don't have the same amount of data as you have for bisphenol A, but you suspect them of having the same, concerning properties.
Right.
So you would actually prefer to have these non-bisphenol alternatives, and for many of the applications, we actually have alternatives already. Mm-hmm. So it should be possible to substitute.
And are these alternatives already on the market? Are they already being used? Tested?
It depends very much on the application. Like for example, bisphenol A is being used to make this hard, durable, transparent plastic polycarbonate. And you can make similar plastic types out of other chemicals, but they might not perform completely as good in some, like, for example, heat resistance or whatever. There could be some, perhaps, places where they are not very good alternatives, but it really depends on the application, because for most applications you would have alternatives.
Okay. Another question from Fadik. Is this problem a global issue, and is the EU leading in the research on this issue of BPA?
The problem, you could say, it's global by nature in a way, because the way goods are manufactured and sold and transported around the world. So a lot of the products we get on the European market are made outside of Europe. And that means, of course, that we need to sort of have a common understanding and approach to this. But I would also like to say that the EU is a front runner when it comes to chemical policies, and also trying to be market leading in having safe and sustainable chemicals on the European market and also in the product that we use.
Mm-hmm.
But it is a difficult problem because there are many countries that have different approaches to this, and yeah.
Yeah. Again, we're almost out of time, but if you have comments or questions, you still have time to put them in the comment section, and we'll get to them. What other work is the EEA doing in this area?
Yeah, well, so we are very much involved in this new research partnership park. And actually, we are really trying to make the research move in a way where it's relevant for the policy developers, like, for example, the Commission, and also for the objectives under the Green Deal, Chemical Strategy for Sustainability. And one of the interesting projects we are involved with is to develop an early warning system where you would try to detect chemicals early on, hazardous chemicals early on, in order to not have people exposed and then you could say react after they have been exposed, but preferable early in the process. And there is also another interesting aspect that's called safe and sustainable by design, mm-hmm. which is a toolbox that should be used by industry when they develop new products to sort of get these safety considerations into the process very, very early in the product development.
So that then at least be given a heads up. EFSA and other EU agencies looking into this will be given a heads up earlier on. Hey, this chemical is part of this product.
You could say, but preferable, you could say the companies that are inventing new chemicals and new products should identify hazards already at an early stage. That could also avoid them spending a lot of money on product development and then finding out later that actually this chemical is not very good.
Yeah. Okay, we're almost out of time. Again, you still have a few minutes to get your comments or questions in. You mentioned the park and what other things, other chemicals are of risk, but are you working on other chemical areas at the EEA that pose a risk to the environment and health?
Yeah, there are lots of chemicals in our surroundings, and it's always, we are always trying to identify where should we put our resources and what are the most important substances to work on. And I can say that at least for the next time, we will be working on PFAS, as many others are also doing. But that's a really important group of substances, I think, to actually work on and reduce exposure to.
Mm-hmm. And what are we looking at as far as the problem of PFAS and EU regulation on that?
From the EEA side, we're not a regulatory agency in that sense, so we are following what's going on, especially you could say the universal PFAS restriction that's being it's underway right now from ECHA. But
the European Chemicals Agency.
Yeah, European Chemicals Agency. Yeah. But we are, our strength lies in the knowledge of occurrence of chemicals. So we are, trying to get data on where do we find PFAS in soil, in drinking water, surface water, in human bodies. So that can, that is a part of also demonstrating or getting data on how worried we should be for this large group of substances.
Okay, great. I think we've run out of time. So again, if you have any more comments or questions, you can jot them in the comment section and we can get back to you after our live stream event today. I'd like to thank Magnus for your time today. If you have any other closing comments you'd like to make, or...
No, not really.
Okay, great. Thanks. Please have a look at the briefing as well, and we'll keep our eye out on the developments on the EU stage regarding this chemical. Join us again next time. We'll be discussing climate mitigation adaptation in a few weeks' time. Look for the event invite on our LinkedIn page. See you next time.